I just wanted to talk through the explanations one more time with our little graphic here. So I made this to try to give you a better understanding of the interplay of those different factors for periodic properties and trends. So again, for this first one, ionization energy and radius comparing nitrogen to phosphorus. Here I have nitrogen shown. When we compare nitrogen to phosphorus, I go from nitrogen and I click on phosphorus. The key difference here, again, is that addition of an additional shell. So from nitrogen to phosphorus, we now have these phosphorus electrons in this much larger shell. That's going to then mean that we have a higher energy shell, which is less stable, so therefore a lower ionization energy. So that's the key difference. Anytime we go down the periodic table, we just go from here, add a shell, gets even bigger, higher energy, easier to ionize. Again, for our next one, arsenic gets even bigger as we add more and more shells. Larger size, lower ionization energy, really straightforward whenever there's just a difference in the shells. For 2 and 3, comparing the radius of these different ions, we can do that using this little charge visualizer. So I'll go to chlorine. Chlorine is, again, has these sort of 7 valence electrons, 3s2, 3p5. If I make its charge -1, I'm going to add an 8th electron, and you can see as you add that electron, the whole atom has to expand a little bit to accommodate it. That's, again, because anytime we add an electron, we're going to have more shielding and a lower effective nuclear charge. We can see that by the effect on the size. So anytime we sort of take, again, in the same shell here, I add an extra electron, all my shells need to get a little bit bigger to accommodate that extra electron. So add electron. Again, anytime I add an electron, that's what's going to happen. Increase my size. Similarly, I can go to iron. Iron +1, +2. Iron +2, you can see going from iron to iron +2, I've removed that 4s shell, and so my size actually has decreased a lot. But now if I remove another electron, okay, anytime I remove an electron, this shell gets a little bit smaller. If I remove an electron, the ion gets a bit smaller, because again, if I remove an electron, now I have less shielding, higher effective nuclear charge. That's going to bring those atoms in a little bit closer. Then for our last comparison here, I'll go up to the isoelectronic ion comparison. So this sort of shows all of our isoelectronic ions here. N3 minus, O2 minus, F minus, neon, Na plus, Mg plus. Let's pick this next one, calcium 2 plus versus sulfur 2 minus. If I look at calcium 2 plus, that's lost its 4s electrons, so it's just that argon core. Now if I look at the difference here to sulfur, I go from calcium and then I click on sulfur. The only difference is I changed the nucleus, I removed those protons. That's going to mean I have a smaller Z effective, and therefore all of my orbitals can expand out of it. Since then, again, that smaller force just allows those orbitals to expand out and get a little bit bigger.